All right, we're back with another episode of the Mastering Blood Sugar podcast, and I have with me here today someone that I've been really excited to interview for quite a while, and I'm honored to have here with me, and that's Dominic D'Agostino from the University of South Florida in Tampa. Dom, welcome to the podcast. Glad to have you here.
Thank you for having me, Brian.
Absolutely. And you are known as really one of the leading scientists in the study of ketogenic diets and metabolism and brain health. This is an area that I think is really interesting when it comes to diabetes and metabolic health for sure. There's been several studies. We've had Dr. Sarah Hallberg and Amy McKenzie on to talk about what they're doing at Indiana University with Virta Health and their studies on ketogenic diet and type 2 diabetes, prediabetes, fatty liver, and so forth. So this is an area that's starting to get a lot more attention. I think it's deserved. But I'm curious just to see how you got into this field or got focused on ketones and ketogenic diet. What was your introduction to this area?
I've always been interested in metabolism and nutrition as an undergrad. I studied that, preferentially I majored in that. The job market was not really that great for nutrition, so I transitioned to biological sciences in addition to nutrition with a double major. And for my undergrad, I started doing research to pad up my application for medical school, and I started doing basic science research on the neural control of autonomic regulation in a pulmonary critical care division at Robert Wood Johnson Medical School, University of Medicine, Dentistry, New Jersey, big long name. And I got sucked into just basic science research. And I did patch clamping and electrophysiology. I did immunocytochemistry. Is really like fundamental neuroscience. So I got so interested in that, I applied for the neuroscience program PhD at Rutgers, and it's part of UMDNJ, the medical school there. So I ended up studying how the brain controls autonomic regulation, sympathetic drive, and also with probably more of a key focus on respiratory rhythm generation, oxygen sensing neurons in the brainstem and how they modulate respiratory drive and how they sense oxygen and all the different neurotransmitters involved. At the same time, I was doing a lot of diving, and that was a passion of mine. And it morphed into this. I wanted to understand diving physiology from a neuroscience level, and I wanted to combine that with neuroscience research. So I did a postdoc funded by the Navy, the undersea medicine program, which basically looked at understanding physiological resilience and neurological resilience in extreme environments, and in the context of a warfighter, deep sea missions, Navy special operations community that use the rebreathers. So there was a lot of questions that are unknown, like what causes oxygen toxicity, what causes nitrogen narcosis, what causes high pressure nervous syndrome, like decompression sickness, all these things. So I wanted to study that, and I got a fellowship to study that in Ohio. And then throughout my fellowship, I moved down to the medical college at University of South Florida, which I've been since 2006, and then moved up the ranks through tenure and now associate professor, applying for full professor. And as I studied brain energy metabolism in the context of oxygen toxicity, which is a seizure, I discovered that the ketogenic diet had been used for almost a century for seizures. And that was like a legitimate application. People pitched the ketogenic diet for everything, but it was actually the standard of care, if you will, for drug refractory or drug resistant epilepsy. So I was like, I can go back to nutrition, which I'm very passionate about anyway, instead of drugs. And I did work on drugs, and I still work on drug research, and that research was always messy. But when we transitioned to nutritional protocols, we kept getting amazing results, with very little variability. It worked every time. It worked profoundly to alter glycemic control, biomarkers, tumor progression, seizure disorders independent of the seizure type. We're studying Kabuki syndrome now, the Angelman syndrome, absence seizures, oxygen toxicity seizures, all these different things that we study. It works every time. So we study the ketogenic diet, and we also study supplementation that can rapidly induce a state of ketosis that is therapeutic in the context of seizures, at least. And we're studying that for glycemic control is a big part of what we're doing. Cancer cachexia, which is muscle wasting associated with certain inflammatory cytokines. So we're, we're studying many different emerging applications of the ketogenic diet, but my core focus is probably still seizures and different seizure types. But it was about 2008 that I thought that I could build a research program on this. And a lot of people thought it was like academic suicide, basing your career on a high-fat diet and then using that as you make your run to try to get tenure. Like, what kind of funding are you going to get? This sounds weird. Is NIH going to fund you? I mean, there was a lot of questions, but it all worked out. I think if you believe in something, most importantly, if the science is good, and I feel we have legit research, and if you just go on Google or PubMed, there's a skyrocket peer-reviewed publications on the ketogenic diet now for type 2 diabetes, which wasn't a thing back when I was studying it. People were doing it, but it's much more accepted now. And even for type 1 diabetes, low-carb diets are actually being accepted now.
Yeah, it's even in the ADA guidelines, at least for short-term use. So that's a huge step in the right direction.
That's right. Yeah.
Very cool it definitely steered your career in a unique direction. So that's something. And it seems like you've done really well and helped all of us really to learn how to use this and how to think about it a little bit differently. If we could take just a step back and look at ketones under a microscope, so to speak, could you talk a little bit more about what the purpose of ketones are? They're an interesting fuel, I think, have a history of being demonized for a long time, and then given new life, I guess, in the early 1900s with the epilepsy research, but certainly given new life recently for metabolic health. So can you talk about maybe what they're for, how they're produced, what their physiological function is? Yeah, sure.
I'll preface it by saying I kind of demonized ketones too. And the ketogenic diet was, I don't know, I just didn't have a very good. We talked about it briefly in my nutrition science curriculum at Rutgers University in that program, and it was just something that you definitely wouldn't want to attempt. I think there was a protein-modified fasting diet that someone died and got protein. They talked about that in the context of ketosis. And maybe we might have mentioned it briefly for epilepsy, but I don't even remember that. So I like to discuss ketones as an intro just in regards to fasting. So if you go in the absence of food, which we no doubt historically did throughout our evolution, your body burns off most of its stored carbohydrate in the form of liver glycogen. And if you're running and exercising, about muscle glycogen. And then we liberate fatty acids for fuel, which are a very efficient fuel source. The fatty acids are used by the heart, not so much the brain, but accelerated fat oxidation, beta oxidation of fatty acids in the liver will produce an excess of acetyl-CoA, and then that can combine to make acetoacetate, which can then be reduced to make something called beta-hydroxybutyrate. So if you fasted for more than 24 to 48 hours, you will start spilling these ketones into peripheral circulation. Interestingly, the liver produces ketones, but lacks succinyl-CoA transferase, which allows the liver to use it as energy. So the liver is kind of sparing it for the peripheral tissues, namely the brain and the heart. So we have these ketone bodies, if we haven't eaten in 2 days, start to accumulate in the blood from the breakdown of fat, or body fat. And they get to millimolar concentrations, which represents a significant amount of substrate for the muscles, for the brain and the heart, and they start accumulating to the level of blood glucose. So we're talking about 2, 3, 4, 5, 6 millimolar. So that's a lot of energy in the blood. So they're small water-soluble fatty acid breakdown products. So fats, generally medium chain fats and short chain fatty acids can cross the blood-brain barrier. The long chain fats typically don't, but ketone bodies use the monocarboxylic acid transporter and essentially are freely cross the blood-brain barrier, and they can largely replace glucose as a primary energy source once they get up into the millimolar concentrations. So our brain essentially starts running off ketones when we've been in a fasted state, and that no doubt contributed to our ability to survive. It's like our adipose tissue contains fat, which allows it to break down fat into these ketone bodies, which is a very efficient brain energy metabolic fuel. We study ketones as an anti-seizure. They have anti-seizure signaling properties and anti-inflammatory properties we think are important for the neuroprotective effects. But we also study ketone bodies as anti-catabolic molecules. And our ability to survive a long duration in the absence of food during fasting and famine, ketones allow that ability to survive long periods without food just by virtue of supplying energy to our muscles and to our brain. Otherwise, if we did not make ketones, the gluconeogenic amino acids in our skeletal muscle would start to be broken down. Not just skeletal muscle, the heart and our organs would start breaking down to make glucose for our brain and our heart. To maintain, there's very powerful homeostatic mechanisms that blood glucose, and you have a balance between insulin and glucagon. And when you're in a fasted state, it's really the suppression of the hormone insulin and to some extent an elevation of glucagon that keeps that glucose level stable. So even in a severely fasted state, it's very rare to go too much below 3 millimolar, so about 60 milligrams per deciliter, something like that. But even if you've eaten no carbohydrates in your... I think the ability to produce ketones, which humans do more than other animals, or historically it's written, but we've studied manta rays, we've studied different animals, and we've measured their blood, and they do produce ketones too. It's harder to get a mouse and a rat into ketosis, but you can do it with specialized diet. So I think it serves as an anti-catabolic effect, brain energy metabolism, and a host of signaling effects. So we know that ketone bodies actually have a receptor, and they activate various pathways that can protect us under stress. And we are elucidating those pathways mechanistically and even from an epigenetic standpoint. So they function as, we think, as histone deacetylase inhibitors, and they can actually activate various gene programs that are associated with symptomatic relief of various disorders that we're studying.
Wow.
So that's a project that we're working on now. But yeah, I think one way to study ketones in isolation is to produce ketone supplementation. And one of the things that we did not expect when we administer ketone supplementation, and that could be a ketone ester, and there's different forms of ketone bodies that can be consumed orally to elevate ketones to mimic a ketogenic diet. And then there's also ketone salts, where ketone bodies are mildly acidic, but they can be combined with a monovalent or divalent cation or amino acids. And in powdered form, they can be mixed up and consumed, and then it produces a mild state of ketosis. One of the things that we observed was that it reliably reduces blood glucose. And we don't fully understand why. We have a couple of theories, but we need to study that a little bit more, and need to study actually what's going on in the liver. The liver is the master regulator for controlling blood glucose in many ways, and we think there's counter-regulatory mechanisms and a host of different things going on. And then ketones can also release a little bit of insulin, which could facilitate glucose disposal. It enhances insulin sensitivity, and for reasons we don't completely understand, reduces glycogenolysis and gluconeogenesis. So like focusing on that. But therapeutically, I think we've studied metformin quite a bit and even had a PhD student do his whole PhD on it. We don't see the level of blood glucose lowering effect with different drugs like metformin like we do with exogenous ketones. So that's kind of like a newer area of research. We're just starting to publish on that now. We're also looking at aging. We're looking at motor function. These are some of the topics I've actually not even talked too much about yet that are ongoing right now that I'm excited about.
That's fascinating. And a great mini lecture there on the physiology of fasting and ketogenesis. I think that was really encapsulated the whole thing really well. So thank you. The one follow-up question to that, you mentioned how acetoacetate gets reduced to beta hydroxybutyrate, and then the other ketone that we think about is acetone. Do those three ketones have different functions? Do they work synergistically? Is beta hydroxybutyrate, which seems to be the one that's measured the most, talked about the most, is that the most powerful or has the most metabolic benefits? How do you kind of look at those three ketones and their function in the body?
Yeah, they're all really very good questions. So we tend to measure beta hydroxybutyrate, and I usually keep my blood meter around here. It's in my drawer somewhere. Because beta hydroxybutyrate is the reduced form, and in circulation, beta hydroxybutyrate is the most stable ketone body. So the assays to measure it's easiest to measure it in the blood because of its stability. And you can even measure it in the urine. So we measure urine beta hydroxybutyrate. And then acetoacetate, or beta hydroxybutyrate, when it becomes oxidized, it becomes acetoacetate, which is still a powerful fuel in circulation. And also understand that before a beta hydroxybutyrate can be used as a metabolic fuel, it gets oxidized to beta hydroxybutyrate, gets oxidized to acetoacetate. And then it more or less splits, and the acetyl-CoA can feed into the Krebs cycle and produce the reduced intermediates to drive the electron transport chain. So acetoacetate in circulation can spontaneously decarboxylate to acetone. And acetone is a volatile organic compound that you can smell on your breath. So physiologically, beta hydroxybutyrate, because of its reduced form and because of its mitochondrial energetic dynamics, it more or less enhance mitochondrial ATP production by oxidizing Q. So the delta G of ATP hydrolysis is higher with beta hydroxybutyrate relative to other substrates like glucose. So from a millimolar perspective, ATP production is quite high with this ketone body. It's a very efficient substrate for fuel, more so than acetoacetate. Although acetoacetate, we discovered, has really important neuroprotective functions and also has some skeletal muscle wasting or anti-catabolic, even muscle regenerative functions. That's another topic. But acetoacetate in like a ketone ester form, which we have a ketone ester of acetoacetate that produces a 1-to-1 ratio of beta hydroxybutyrate and acetoacetate. The anti-seizure effect of acetoacetate may be due to acetone. We know acetone seems to influence a number of things, perhaps a potassium channel, which can hyperpolarize the resting membrane potential of neurons. And when a neuron is hyperpolarized, it's less likely to be hyperexcitable and to fire too many action potentials. But acetone is really not a very good metabolic fuel, and it can be toxic, but we're talking about subnarcotic levels of acetone in the context of a ketogenic diet and even powerful ketone ester supplements. I guess you could get a level of ketosis that would be toxic level of acetone, but there's counter-regulatory things that would probably prevent that from happening. But we think of acetone as nail polish remover and caustic, a compound that can have pretty harsh effects on membranes. But in small amounts in circulation, it seems to attenuate hyperexcitability in the brain, and that seems to be beneficial to people with seizures and epilepsy. So breath acetone correlates well with seizure control. The higher the breath acetone, the better seizure control in kids who have seizures. So there's at least, I think, 2 publications on that. In animal models, it's definitely the case, but I think human data to confirm that. So we're interested in all the ketone bodies, and we developed supplements that for motor function, we develop formulations that would give higher levels of beta hydroxybutyrate. And for certain neuroprotective functions, we develop things that would be more, that would elevate all the ketone bodies together.
Okay, very cool. You talked earlier about fasting and how ketogenesis is upregulated during total starvation or fasted states. Where does the high fat component of a ketogenic diet come in? I think that's somewhat confusing to a lot of people, and that can be often what gets people in trouble with the ketogenic diet. So if not eating at all would put you into a state of ketosis, how does the ketogenic diet do a similar thing, and where does the fat component of that come in?
Yeah, a good question. So the benefit of a ketogenic diet, it was observed for decades, centuries, millennia, even, that fasting was a powerful way to control seizures. So therapeutic fasting produces therapeutic ketosis, right? And it was observed that this state of ketosis had a pretty profound anti-seizure effect. And studies that were done by the Mayo Clinic observed that diets that were like 90% fat with adequate, sufficient protein, enough to prevent protein malnutrition, just enough to prevent protein malnutrition. They added a small amount of the suppression of the hormone insulin. So by suppressing the hormone insulin, that facilitated release of fatty acids, triglycerides into the bloodstream, and fatty acid oxidation in the liver to make these ketone bodies. So a ketogenic diet mimics, not completely, but many aspects of fasting, and most importantly, the elevation and sustainment of ketones over time, because fasting obviously is not, you can't sustain that indefinitely if you're trying to manage seizures, right? You got to eat at some point, and chronic calorie restriction is not feasible either. So especially for kids where the diet was used most routinely, that you need to have a eucaloric diet, which means you get enough calories to maintain your energetic needs, and even titrate the calories so you have some calorie surplus. And protein's important too. The early diets stunted the growth of kids because the protein was too low. But now we know we can be more liberal with the protein. It doesn't have to be 8%. They've titrated up to 12 and 15%, and even in some cases use a modified Atkins or modified ketogenic diet with upwards of 20% or more protein, and still maintain a state of ketosis. So if you add too much protein in, protein has an insulinogenic effect, not as much as carbohydrate, but you'll get a release of some insulin, and that insulin is anti-ketogenic in that it will, in some cases, converts a little bit more towards glucose, but it stimulates insulin in various metabolic pathways that turn down the production of ketones. And then the diet is not as therapeutic if the protein content gets too high. So we were really concerned with the protein back in like the 70s, 80s, and 90s. But Eric Kossoff had studied the ketogenic diet in adults and demonstrated that the modified Atkins diet had anti-seizure effects. So clinicians who are prescribing the ketogenic diet, at least for seizure control, they'll start off with a classical ketogenic diet, which is like very high in fat, like 87% fat, and then adjust the ratios to allow for more protein. And then it's more feasible for patients to follow a diet that's more liberal in protein over time. But it's really that fat, the dietary fat, as opposed to our body fat, the dietary fat that's contributing to the ketone production. And the restriction of carbohydrates is a major component, probably the most important component, and the restriction and somewhat moderation of protein is also necessary to get that induced state of ketosis and maintenance of sufficient ketone levels.
That's interesting. So it's the dietary fat that's actually driving ketone production. Now, in someone who's type 2 diabetic and significantly overweight or obese, in that case, maybe you want to decrease the fat consumption a little bit to help them increase the use of their own body fat stores.
Yeah, absolutely. I think for weight loss and type 2 diabetes, which usually is enhanced with weight loss too, you need to titrate the calories down. There's no real way to lose weight without going into a calorie deficit. What we routinely see is that higher protein and fat intake with carbohydrate restriction has an appetite suppressing, maybe appetite regulating effect, where it's controlling your appetite to the extent where the appetite's not controlling you. And by virtue of moderating glucose fluctuations or attenuating spikes in glucose, and also controlling the hormone insulin, your energy levels tend to be more stable, less fluctuations. And this can promote a physiology that's in line with helping eating behavior and helping to attenuate a lot of the cravings. Because if you go on a reduced calorie diet that's high in carbohydrates or has a greater proportion ratio of carbohydrates, you're going to get glucose and insulin fluctuations, and the postprandial hypoglycemia will be a powerful trigger for eating. And so it's really important glycemic control is really important, obviously for type 2 diabetes, but also to really control eating behavior in a way that does not promote cravings and things like that. And I think there's a little bit of debate in the community. People say it's the protein, but it's really like the hormones that are being released from protein and fat, like cholecystokinin, GIP, and GLP-1. There's a whole leptin. There's a whole host of things that the metabolic and physiological effects of low carbohydrate diets seem to be favorable for sustaining that weight loss. It's easy for people to lose weight and get their glucose under control. It's very difficult to sustain that weight loss. So the criticisms of low carb diets and even ketogenic diets is that they're not sustainable. I would argue, no, I think they're more sustainable if you can just stick with the types of meals, and gravitate towards low carb nutrition. You'll find that it's physiologically more sustainable. From a lifestyle standpoint, people have to make that decision.
I think, to be fair, I don't know that any diet has been shown to be sustainable other than eat whatever you want, because anytime you're putting restrictions on people, it's human nature to want to, unless you've tuned your physiology, you have some good reasons for wanting to do that. I think it seems to be human nature to want to rebel or to veer off track with the diet.
I think the hedonic effect to a combined sugar, fat, salt stimulus is very powerful. I teach dopaminergic signaling and things like that. And we have some fMRI images, dopamine hits and suppression of dopamine in people who have these eating disorders when they're deprived of food. And that level of dopamine depletion would not occur in someone, for example, who can track their macronutrients. I think tracking is really important. And there's a lot of great apps out there. Carbon Coach app is really good. Chronometer. Wearing a continuous glucose monitor, which I have a series of experiments lined up that I'm going to do over the year. And I just did a 2-week experiment with a 3-day fast towards the end. wearing a continuous glucose monitor is a really good audit of your eating behavior. For me, it was very insightful to see what happens if I overeat protein or binge on carbohydrates at night, which is a kind of a common behavior, especially in people who do intermittent fasting, where you're just like, I'm not going to eat all day and I'll just eat my one meal at night. And then your meal tends to like span over 4 to 6 hours where you're susceptible to overeating. Glycemic regulation at nighttime and your sleep can be dysregulated in ways. So for me, it's always a learning experience. There's some things I expected and some things that I didn't expect, but I think it would be super helpful. And I think insurance companies should pay for this for people who have pre-diabetes even, but definitely with type 2 diabetes, to use a continuous glucose monitor and be able to audit their eating behavior and their food and meal selection.
I think it is the most effective disease management tool available. And I'm surprised that it's not routinely recommended for people with type 2 and prediabetes, because it would end up saving insurance companies a ton of money over time. But what did you notice on your CGM from doing the higher protein or carbohydrate and so forth? Any clinical pearls there that you can share?
Yeah, so there's some questions that I really can't find satisfactory, unambiguous answers to in the literature. And one is, how does a isocaloric meal, if it's higher in protein, if that protein is mixed with fat and fiber, the same amount of protein, what influence does that have on the glycemic response? Fat and fiber have a very powerful attenuation of that spike. So I was really surprised at how eating just like a chicken breast, or especially eating like a liquid protein meal, various protein powders people send me, even plant-based protein, whey for sure, gets a spike in glucose and in insulin. So I measure insulin too, although it's a little more expensive to do it. I do it occasionally. But I can get a pretty robust glucose and insulin spike from a liquid protein, from eating just low-fat protein, but protein that is combined with fats and fiber in the form of insoluble fiber, a small salad. It could be like a garnish even. Just a little bit of fiber can go a long way in attenuating that. It does. The area under the curve is not so much changed. It is less, but that spike, so the postprandial spike is much. With a continuous glucose monitor, I've observed I eat the same meal 3 times at the same time of the day. And on 2 occasions, I went for a brisk, we walk our dogs after the evening meal for about 20 to 30 minutes. And it's not physically challenging at all, but that really plays a big role in attenuating that spike. It's knocked down in half, maybe even like 70 or 80%. And then I actually go hypoglycemic for a while, but not pathologically. I felt fine.
Sure.
Based on my sort of observations, just getting your body to move for even 10 to 15 minutes can facilitate non-insulin dependent glucose disposal. So we know when we're moving our muscles and we're doing things, the GLUT4 gets translocated to the muscle and can help pull in glucose from the bloodstream. So I think mild to light physical activity after large meals especially, it's like something that's really important. I never even really gave this much thought, but I guess looking back, maybe there was recommendations to doing so, although some people say rest after a meal, but very light activity can go a long way to improving your glycemic control. And even drinking a large glass of water before eating the same meal, and then doing an experiment where I'm drinking about 20 ounces of just pure water, not like a Diet Coke or anything, just like pure water, and then eating the meal, that alone can actually decrease the glycemic response. I don't know, hydration maybe affects insulin sensitivity. It may be diluting the blood you're probably hypovolemic for a little bit, but your kidneys have pretty good control over your state. So I think, so some of the things that I learned, drink a glass of water before a meal, do physical activity after a meal. Interestingly, if I do intense physical activity that gets my heart rate over a certain threshold, my glucose spikes up. So you're activating the sympathetic nervous system, which is increasing glycogenolysis. You have glycogen stored in the liver, and it's breaking that down, releasing it into the bloodstream. So I wouldn't be worried about that, but I do notice that people on ketogenic diets that do like intense training, I notice from their CGMs that they have a pretty high glucose spike. Not that that's necessarily pathological, because during all the other times with meals and everything, the glucose tends to be lower. But these are some of the things that I've observed, and I want to follow up on and do some experiments on macronutrient ratios and the glycemic response to different macronutrient ratios, with and without fiber and different kinds of fats and stuff too. I have it all laid out in my next series of experiments I'm doing.
I think that'll be incredibly practical research that I'd love to follow up with you on and find out the results so we can share that with people.
Yeah, and
really
if you're patients, I know you have a lot of, I'm always interested in learning from feedback from other people. These are questions that not only me, the various organizations that I'm connected with have these questions, and I've been wanting to explore these questions by sending people CGMs to do their own experiments. But I think the information that we can get, and that can help to guide our recommendations, because I'm very interested in simple things that people can do that can really keep tight regulation over their glycemic response, that'll pay big dividends later on in life. Because those prandial fluctuations up to 300-400, that's really going to take a hit. That's going to take years off life down the road. And I think these can be not abolished, but significantly attenuated with very small behavioral things.
Incredible information. And we're getting close to the end of the hour here, but I just want to bring it back to something a little bit more simple and basic as we get close to finishing up. And that's just some of the benefits of having circulating ketones. We have talked about a few of them. You talked about appetite suppression as a potential benefit, I believe, certainly on a ketogenic diet. But what are some of the other benefits, maybe even independent of the ketogenic diet? What are some of the benefits of having elevated levels of blood ketones?
Yeah. So I would say, first and foremost, probably it attenuates the physiological negative effects of hypoglycemia. So I think in the context of type 1 diabetes, is that this could be very important because it makes you resilient against the potential negative effects of hypoglycemia, which is brain fog, which is if you're type 1 diabetic and you're driving and your blood glucose goes low, that could be a very dangerous situation. But if you're on a ketogenic diet, or you're maybe even taking ketone supplements, the ketones can come to the rescue and help to preserve normal brain function. It needs to be studied more, and we know the ketones can impact ghrelin too, and that can have an appetite suppressing effect. And this is work done with ketone esters, but there's also other signaling molecules that come into play. But the appetite suppressing effect of elevating your ketones, I think from a real world practical standpoint, that can be very beneficial. We're really focusing on, I've noticed over the years that my inflammation marker has gone down a lot. High sensitivity C-reactive protein is something I measure every 2 months. And that's almost like non-detectable unless something happens. Like I was traveling overseas and had a small stomach bacterial bug. And that it's amazing when your GI system becomes compromised, how that activates your immune system. But the ketogenic diet, I think, can actually promote good gut health over time. Sometimes if I travel, I go off the diet, and sometimes I pay for it. But generally speaking, I've not been sick God, I can't remember. Maybe I've had a cold over the last 2 years. Maybe I had the sniffles twice, but I've never got the flu, respiratory virus. I've never occasional like little stomach bug. We've traveled dozens of places over the world, and I usually shake it in 24 hours. So I really do think that the metabolic health effects of a ketogenic diet and perhaps the ketones themselves may be suppressing your systemic inflammation. And I think of your immune system as like an army. If something, is causing inflammation, the army is out working on that. And then if you have a foreign, like COVID-19 or another bug come in, there's less resources to deal with that. So because I'm in such a low inflammation state on a ketogenic diet, my immune system is much more vigilant to attack and deal with potential pathogens like viral and bacterial pathogens. Also, from a prevention standpoint, it's the vigilance of your immune system that finds cancerous and precancerous cells. And so work done by my colleague, Adrian Scheck, demonstrated that there were changes in immune regulators that made the immune system more vigilant to identify and attack cancer that's in your body. And we're always producing like precancerous and even cancerous cells, but our immune system, if it's in a heightened state, can deal with that. But when our immune system fails, that's actually a hallmark of cancer, is just there's not an immune recognition of the cancer, so it can grow. You have unbridled growth and then a tumor forms. So these are some of the practical benefits, I think. And from an energetic benefit, I can go, like if I'm fasting today or tomorrow, I have sustainment of energy. And I think if we open up and induce a state of ketosis, maybe 3 or 5 days out of a month, we're activating that metabolic pathway. And just like muscle memory, there's metabolic memory. So when we fast again or transition to a ketogenic diet, we get into a state of ketosis faster. And we have some animal data to show this. And I always knew it was the case, but now I think we have some data to show this, that you enter a state faster, it's easier for you, and you derive more benefits the more you do it. So I think these are some practical things that if people, understandably, a lot of people just don't want to do the ketogenic diet all the time. But I think if they fasted 3 days a month, or they just did a low carb diet 1 week out of the month, you start to get a lot of benefits of ketosis with that.
Yeah, that's fantastic. Okay, great. We're going to wrap up here in just a minute. I do have 2 quick questions that I like to end all these interviews with, which I'll ask in just a second. But before I do that, would you mind sharing your website and how people can find out more about what you're doing?
Sure. I have a one-stop shop for the website. I don't sell any products or promote any products. I do like to test products, and I put those products on the website. And as a disclosure, some of the products that I really like, sometimes they give us affiliate links, and that any income from that can actually go back and help our research. So that's how we work that. But Keto Nutrition, all one word, .org. So ketonutrition.org. And we have a blog. There's consultants on there for people who need a dietary consultant, reviews of products, and we approach a wide range of topics in the blog. And subscribe to the newsletter too, Keto Nutrition. Whatever I'm testing for the month or for the week or whatever, I send the newsletter out and I talk about my experience using CGM, our travels, what different products are out, a range of different topics in the newsletter.
Okay, very cool. Also, I know you have lots of great videos on YouTube, so I would recommend checking out Dom on YouTube as well. Just a couple quick questions to wrap up. And the first one is there a book that you read somewhere along the way, either recently or in your past, that had just a huge influence on you, maybe changed the direction of your personal life or professional life, or opened your eyes to something you hadn't thought about?
Yeah, I think, wow, there's so many. I don't know. I do like to read, whether I'm usually reading a book constantly or listening to an audiobook if I'm driving and things like that. But yeah, going way back, we all know Anthony Robbins has been like a big influence on me. Power and Awakening the Giant Within were pretty big books. And the book I read it when I was not quite ready for it, but the book, The Screwtape Letters by C.S. Lewis, actually had a pretty big impact on me. And it's more like philosophy, Christian philosophy. But only 10 years later, when I reread it, did it really resonate with me and probably change my kind of outlook on life for immensely beneficial, direction.
Wow. Very cool. It's very interesting. I haven't heard of that one before. Thanks for that recommendation.
Yeah, check it out.
And lastly, if you had a friend or family member, someone close to you, come to you with the news that they had just found out they had type 2 diabetes, they got a diabetes diagnosis, and they just asked you for your best advice, what should they do to get themselves on the right track? What would be the first thing you'd tell?
I think nutrition's probably one of the most powerful levers to pull when it comes to managing your type 2 diabetes. And it needs to be a continuous effort. And it's hard to change nutrition if you don't really understand what your current nutrition is. So I think simply keeping a dietary log, whether that be in a written notebook or many of the apps that are out there, Carbon Coach app or Chronometer app, and to understand what you're eating and taking a step back and determining where you can make beneficial changes. It's small changes can make really big impacts on your glycemic control. And I've learned that myself. Although I have pretty good glycemic control, there's always room for improving that. So I think people really need to understand. And also there's a lot of resources out there. Verta Health is doing a lot of research, but low carb diets are very powerful. And I think you want to work with a practitioner and someone knowledgeable with the administration of these diets to do it the right way. You don't want to go on a starvation diet. You want to get enough calories, macronutrients, and micronutrients that you need, and to be able to adjust and tweak along the way as your body adjusts to the diet.
Yeah, I think that's great advice. Excellent. Thank you so much for your time today. Check out Dom at ketonutrition.org, ketonutrition.org. Subscribe to his newsletter there so you find out all of his latest experiments, the things he's testing and doing. Check him out on YouTube. And Dom, thank you so much for spending the time here with me today.
Thanks for having me, Brian.
All right, thanks. And everybody stay tuned. I'll be back next week with another expert interview. Thanks very much.